viewers, I am Rijesh from Zero Wave. If you have not yet subscribed my channel, please do it right now. And don't forget to press bell icon for further notifications. In this session, I will be explaining chapter 3, Understanding Quadrilaterals. Basically, geometry is a branch of mathematics which is concerned with shapes, sizes and its properties. We can draw all these shapes in a piece of paper, whiteboard, wall, floor, etc. These are planes. So, in a geometry, a plane is a flat, two-dimensional surface which extends to infinity. Then, what are curves? Curves are smoothly flowing line segments which can be drawn in a piece of paper without using scale or ruler. There are three different types of curves. One is open curve, one is closed curve, one is simple curve. Let's see what is meant by open curve. These two are examples of open curves. So, open curves are the curves whose endpoints do not meet. That is, the starting and ending point of these curves are not meeting. And what are closed curves? Closed curves are the curves which do not have any endpoints and completely encloses some area. See, these are examples of closed curve. Okay. These are examples of closed curve. And moreover, this encloses some area. Right? Yes. Okay. Now what are simple curves? Simple curves are the curves which do not intersect itself at any point. These are all examples of simple curve. Here you can see that these curves are not intersecting itself. But in this curve you can see this curve is intersecting itself at one point. Right? So this is not a simple. If we are considering this also not a simple, because here this curve itself is intersecting at many points. 1, 2, 3, 4, 5. Right? So this is also not a simple. A closed curve has three parts. One is interior of the curve. This is interior of the curve. Okay. And one is on the curve. That is on the boundary. On the curve. Then this is exterior of the curve. Right? So in a closed curve there are three parts: interior, exterior and on the curve. We have a point as the basic unit of geometry. If we are considering 2 points, then we can make a line segment using these 2 points as endpoints, right? Yes. So, using 2 points, we can make a line segment. If we are considering 3 points, then again we can make a line segments. But these points are in a line. So, these points are known as collinear points. Okay, and if we are considering 3 non-collinear points, then we can form a triangle, isn't it? Yes. And if we are considering 4 non-collinear points, then we can form a quadrilateral. If we are considering 5 non-collinear points, then we can form a pentagon. If we are continuing this process by using 6 non-collinear points, we can make a hexagon. Using 7 non-collinear points, we can make a heptagon. Using 8 non-collinear points, we can make an octagon. For 9, nonagon. For 10, decagon, and so on. All these figures are simple and closed curves which is made up of line segments. So these are known as polygons. What? Polygons. So what is meant by polygon? Polygon is a simple closed curve which is made up of line segments. And this word polygon derived from Greek words poly and gun. Poly means many and guns means angles. That is, polygon is a figure having many angles. Right? In any example you can see that there are many angles. Now in a polygon, these line segments are called sides of the polygon. Let us consider this quadrilateral ABCD. Okay. Then the sides of this polygon are AB, BC, CD and AD. Right? And what are vertices of a polygon? The points where the sides meet are known as vertices of polygon. Here A, B, C and D are vertices of the polygon ABCD. Clear? And what are adjacent sides? The pair of sides which meets at the same vertex are known as adjacent sides. So here if we are considering this D, the vertex D, then these are the adjacent sides. CD and the AD are adjacent sides. And DA and AB are adjacent sides. BC and DC are adjacent sides. And here AB and CD or AB and DC are not adjacent sides. Okay, that are non-adjacent sides. What are adjacent vertices? The endpoints of same side are known as adjacent vertices. Here you can see that C and D are the adjacent vertices of CD. Right? Here D and A are the adjacent vertices of the side AD. Clear? Diagonal of a polygon is the line segment joining any two non-adjacent vertices of a polygon. So here this is the diagonal. This is one of the diagonal. Okay. DB is the or DB or BD is the other diagonal of this polygon. Clear? Now what are regular and irregular polygons? Regular and irregular polygons. A polygon having all of its sides are having equal length and all of its angles are having equal in measurement are known as regular polygon. For example, in an equilateral triangle, we know all the three sides are equal and all the angles are 60 degree. Isn't it? Yes. So this is a regular polygon. Okay, all the sides and all its angles are equal. And if you are considering a square, in a square also we know that all its sides are equal in length and all its angles are 90 degree in measure. Right? Yes. So these two are examples of regular polygons. And if we are considering a pentagon with all of its sides equal, then this is again a regular pentagon, right? If all of its sides are equal, then we can say that this is a regular pentagon. That is, when a polygon is both equilateral and equiangular, then we can say that that polygon is a regular polygon. And the polygons which are not regular are known as irregular polygon. Let us consider one rectangle. In a rectangle, all of its angles are 90 degree, but only its opposite sides are equal. Right? Rectangle is an equiangular but not equilateral. Okay, if we are considering rhombus. In a rhombus, we know that all the sides are equal, isn't it? But the angles are not equal. So it is equilateral, rhombus is equilateral but not equiangular. So these are examples of irregular polygons. Now, the polygons are classified into two, that is convex and concave polygons. What are convex polygons? In a convex polygon, all of its interior angles should be less than 180 degree. For example, we are considering a rhombus, a triangle, a pentagon. Okay, in all these polygons you can see all the interior angles are less than 180 degree, right? Yes, all of its interior angles are less than 180 degree. In this type of polygons, all of its diagonals should lie in the interior of the polygon. Okay, we have already seen what are diagonals of the polygon, right? So it's a line segment connecting any two non-adjacent vertices. So if we are considering this diagonal, which lies inside the polygon, if we are considering this diagonal, which is also lies inside the polygon, and for a triangle, we cannot apply this because a triangle does not have diagonals, because we cannot find any non-adjacent vertices here. And here also we can see that all its diagonals, this is one diagonal, second diagonal, third diagonal, everything lies inside the polygon. Okay, so these are the peculiarities of convex polygons. And the polygons which are not convex are called the concave polygons. That is, in a concave polygon, at least one of the interior angles should be more than 180 degree. For example, we can consider this is a concave polygon. Here you can see that the angle, this angle is more than 180. Isn't it? So this is an example for concave polygon. If we are considering another example, here also you can see that two angles are more than 180 degree. So in a concave polygon, at least one interior angle should be more than 180 degree. And in this type of polygon, at least one diagonal should lies outside the polygon or exterior of the polygon. Here, these two are non-adjacent vertices of this polygon. We have seen what are the diagonals of a polygon. So we can form a diagonal of this polygon connecting these two vertices, non-adjacent vertices. But this lies in the exterior of the polygon, isn't it? In this polygon also, you can see these two vertices are non-adjacent vertices. So we can make a diagonal through these 2 points, isn't it? Yes, this is lying in the exterior of the polygon, and these two are again two non-adjacent vertices of this polygon, and we can form a diagonal which is also lies outside the polygon or in the exterior of the polygon. So in concave polygons, at least one interior angle should be more than 180 degree, and also at least one diagonal should lie in the exterior of the polygon.